Hello everyone, Peter here, Piotr Fissner. Guys, so in today's episode, yes, we will try to fight for our right to repair by fixing more devices and showing people that, that things can be fixed or not, and showing them that we need to do something about it. So today we've got an inverter, which is this model, okay? We've got it in the description anyway. I was showing it the other day. A huge transformer, yes, toroidal transformer. They are really nice. These are really nice transformers used mainly in the audio equipment. These are like these are not the regular switching, power supplies. Yes, when they are having this, but it's less and less common to use them. People like to save money switching power supplies like this here. Yes, that's the switching part. It occupies less space and so on. But this is not exactly switching, like just to show you that bunch of electronics versus toroidal. Yes, so everything has their own purpose. Yes. And this company decided that they want to put pure sine wave, that means better quality for the customer, yes? And they've built this in a bit different way than I'm used to with inverters. When I'm working with switching inverters, yes, it's pretty much simple how to fix them. I see that the pure sine wave is a bit more complex, and you've got a chipset which is driving, this whole thingy. Now, I've got a voltage here coming in. I've got here, let's put 12 volts on it. Okay, so let's switch it on. Yes, let's put max amps current here, and let's go up to 12 volts, okay? Look, it did try, you see, it did try to take some amps. You see, it just trying, but it doesn't allow to go. Really trying to be gentle to reach only 12. Wow, with a course not fine, I've managed to go to 12, which is great. But anyways, 0, yes. You can hear ticking noise, okay, and then when I'm maxing it out, nothing. If I'll even do max, I'll switch it off, yes, and I'll put it on. It will try to go to 0.1 almost, and then goes down. So that means this is not taking current. If it doesn't take any current, that means the incoming power has either chipset faulty, or fuse blown. But no, it can't be fuse blown because of this amps here. It was trying to raise and immediately dropped. So in this case, there is something on the way. To save us time, I went through, checking this part, which is a switch. Yes, so this is there are two modes. One is eco, second is always on. Let's switch it off. Let's see if there will be any difference right now. 0.10, yes, so I'll make one more test, and goes down, yes. So you see, so it doesn't make huge difference, yes, off 0.11 even, yes. And on the option 2, yeah, same story, yes. Sorry guys for the sun, but it's really bright outside. Yeah, this, you see, same story, yes. So it doesn't even matter which setting we are on, it still doesn't want to give us any power. So let's try to see if we can measure where do we have this power going to. So as you see, there's no even light here. Yes, no LED is either if it's on or off. Completely no light. So let's try if we can follow the schematic and find why this 12 volts doesn't go into here. Okay, because that's, I don't know if I will be able to be true, but we can for sure try it. Okay, so now I see that I got it. Whoa, which one it is? That's this one. Okay, so that's a bit too high, but probably I can't do anything. It would be better to have DSLR here installed, but at the end of the day it's fine. So what I want to say is that's a minus, because we've got a black wire connected to this, so that has to be plus. So minus and plus, yes. Now this goes on the side to some small, oh no, that's just solder, so that goes somewhere in and then going somewhere out. What else is happening? It comes to here. Okay, what do we have on this side? We get capacitors. So let's see if those capacitors have any voltage. Oh, we can see here, yes, 220 microfarads and 25 volts. Okay, so we should see some of the power on these. Let's get the meter. DC, let's do 200, and let's see if we've got any volts, plus and minus, and we've got minus and it's plus is on the other side. Okay, so let's do like this. We've got 8 volts coming in. What about the second one? You need to go through the 12 volts. You see, so the power is coming into these capacitors. Now the top one again, because I think I didn't break through the how we call it, the paint. Yes, 12 volts. Okay, so I didn't, there is a layer of paint because that was with wave soldering. You can Google what this mean or YouTube it, it will show you. And then the whole surface was covered in the clear paint pretty much. Yes, you can call it like that, because that's an insulation, which is good for inverters which can work outside, let's say, to give this extra protective layer. But you know, it's not always good for us to work with. Yes. So we've got 12 volts coming in. We see that clearly that the 12 volts comes in, so the incoming power is okay. Now when we are going to this side, because that's the case. Yes, those are the two. Oh, I've got short wires. Then we've got capacitor connected to here. Okay. So on the sides of this capacitor we should have some plus and minus. Don't know why we don't have 12 volts again, but oh yeah, there is 12 volts, but it's not through this. What about here? It's 12 volts as well on the second one. Okay, so we've got 12 volts on them, but is it 12 volts on this? No. Okay, so we just go to this. So the outside one is 12 volt. Okay, so the outside is 12 volt. So in that case, that's mean that on these pins, whatever they are, yes, we've got 12 volts. Here is something which we can't see, that's 1004 resistor. So when there are 3 digits, I know, but when it's 1004, I think it's 1 kilo resistor. So let's see how much will be here. No. Okay, so this is minus and this is plus, which is okay. It's just that because of this paint, it's quite challenging. So okay, so this resistor at least going taking the power off it, so through it, yes. So that's mean, you know, we're okay. So we've got 12 volts here because of that, yeah. So that's fine. We've got 12 volts here as well, yes. So that's what we see. Where are we? Where is my finger? Oh, here on this pin. So we've got it here. So the power goes through this, let's say this part here, okay. And now the question is where it's going out, yes, because that's the main question. Let's keep pressing the minus and let's continue this journey. I don't see by the design, I'll show you here. I don't see by the design, like this is a minus, this is a plus, okay, this is a plus as well, and that's connected and that has power. So if we see that we've got minus, plus and plus working, yes, then that's mean this thingy here, whatever it is, yes, is doing its job. It's probably thermal or something for short circuits, but I'm no expert in them, so don't quote me. You can Google yourself, probably you'll be smarter in 5 minutes of Googling it than I am. But anyways, you know, long story short, so it is working, yes. If it works, that's mean, you know, this is some fuse or something, and this is connecting, and that's giving us 12 volts here to this board. Now this board is taking this 12 volts and need to take it to the power switch, yes, and to some PWM, power management. When it gets that power to them, then that power can be transferred, yes, further from this place here, yes, through that power management to these places here. But as you might guess, probably it doesn't do it because we don't have that power. So I know it's not zoomed in, but let me try get anything here. Look, we've got you don't see, so I'll do it here. Yeah, so I'll touch the same place. These are these places I'm touching. They need to break through. Oh, now there's 0 volts. So you see, we've got 12 volts coming in. That was my just guess. That was my guess, and you see we've got 12 volts on them. 12 volts on each. No, that's a minus, and that will be minus as well. Yes. So in this case, we know that the power is stuck somewhere. Yes, because we've got those 2 points where we have 12 volts, those at the bottom here, and we've got those legs here that will probably have 12 volts as well. Yes, and now this, the question is, does it have 12 volts? Of course it doesn't, but will be 12 volts in between these two? No, there is no, it's minus 0.1, so it's a plus and minus. That's correct, because that should be plus. Okay, so there is nothing, but when I'll take it to the minus, it's 12. Cool, happy days. So in that case, we can't have on these outlets here at the bottom alternating current. Let's get to 720 AC, and let's flip this board. Okay, let's flip this board and let's test it out. We've got 1 volt. Let's do to 20. Look, we've got 0 volts actually. Yes, so that was some tolerance. When you try to touch it, it's there, but it's just going off. Yes, so you see, so we don't have here. We do have a power coming in to the main rail, which are those transistors, MOSFETs, or whatever they are. Yes, to the main rail of it, but then we just ending up with no power, completely no power. So, yay. Okay, so this is what? That's fluctuating. Okay, so that we need to switch to this. Yes. We need some minus. That's a plus in the center. Well, it was a plus anyways. Fluctuation. So in that case, the power management doesn't work, okay? So we can neglect even the power switch. Now that's on a position 1. Now we would like to test it on the position 0, 1, and 2 while holding these thingies. Okay, on, no change, and off, no change. I need to go to my son. Hold on a sec. Sorry guys, I'm back. So anyways, to sum up, yes, we've got an incoming power which comes in here, doesn't short circuit but doesn't go through. When we switch on the power, we see a bit of amps kicking in and automatically going off. We see that on the main power rail here, on this side, yes, we can see that the power which comes in goes to this rail here automatically, extending this power rail to this power rail. And you can see, if you have a close look up, that there are dots here. I don't know if you can grasp it on this, but we can take it under the scope. Yes, you can see those dots. Those are vias. Okay, vias are transferring this to another place, and this is the power supply section which we're looking at under the microscope. And then when we go further underneath this black thingy, here, let's have a close look up. You see, then we've got these dots as well here. So that power comes to this, and without even checking it on the meter, I'll know that it will be short circuited. Yes, let's switch off the power. Let's get our probes here. Okay. We got it, yes. And let's get loud. Oh, you heard it? You see? So that's what this means. I knew automatically that and the plus and the minus had to be transferred here to this lower section, just because when you've got when you've got power management, then it's using, let's say, this chipset. Yes, if that's the case, we will see what the chipset is. If that chipset is driving these here, let's call them MOSFETs because I don't know what they are, to be true. Maybe they are transistors, maybe they are MOSFETs, but it doesn't matter. Yes, it's okay. So let's say this is driven by this chipset. So when the power kicks in, it's only taking a small amount of power, but if chipset can't drive it because it's faulty, then automatically what this means, we can't have power on this side. Yes, because this has only the power transferred, but the power management don't give the signal impulse for these to start working. Yes, so that's what I see it's happening right now. So I don't need to test it any further, and we could, but pretty much there is no value. I would go immediately for that chipset, which I know that is. I checked this chipset as well here. Okay, so it's, where is mine is here. Let's get to the DC 20. Yes, I've checked it. C 0.2, 0.1, it's nothing. I know that I count this diode. Nothing. 0.2, 0.1. You see, so in that case, we count, even if we will change the mode. Point 2, you see? Nothing written. What would interest us on the display? So guys, in this case, we know that even though this power comes in, which I think I was checking this chipset now when I'm looking at it. Yeah, I think I was looking at it. Yeah, I did, because I see that there are marks of me picking this. So yeah, okay, let's try to see if we've got a power on this. Okay, where is the pin number 1? Here. So it's looking like here we could. Nope. It's wrong. Usually pin number 1 is the pin which. And the problem only is with this film here. That's why I was poking, I think, these. You see, that's the problem with this painting on it. Because then you want to test something properly and you count. So we need to get the specification of this chipset and then only check what pins are responsible. Okay, I switched off the. If I would only switch on the meter, then we would have probably even on this diode here reading some reading. Yes, we've got 2 volts, exactly. 2 volts comes in. Yes. So now this chipset, we can test this chipset. Yeah, we've got 2 volts as well. So you see the 2 volts comes in from here and comes to here. Now the question is why there's only 2 volts. And does this chipset require only 2 volts to work? Because that would be a bit weird. I wouldn't agree that 2 volts might be enough for this chipset. That's quite interesting actually. It's 2 volts. Yeah, 3 volts I would believe in, but 2 volts, I think it's just my connection here because of this how you call it, paint on it. Yes, so yeah, 3-4 volts, I can believe that, you know, this should be something. And now when it comes to this chipset, we don't know what the voltage is. Can just assume that it's enough. Oh look, I will believe that it's about that, but not, you know, and it's dropping. Yes. And what about the one setting? Okay, so on the setting 1 it's nothing. You see, I hate this paint. Literally, I hate it. Okay, so sometimes it's connecting, sometimes it's not. But then again, you know, if we've got here nothing, like just a few volts which are dropping down on the AC, and of course we'll have nothing on the on this as well, of course, because that's a DC, so it won't show anything. Yes, so yeah, so we know that the power is coming in to this chipset, and we need to verify what the chipset is, because for me, yes, for me, if I'll check what is the VCC on it, yes, like voltage coming in, yes, then I'll know, I won't be guessing. I can't read, guys. Is trying to get another type of, you know, like a light, and on it it's a bit different. Now STM32F, that would be the case. STM32F, what it is, STM32F. Yeah, there is some chipset called STM, but that's ARM Cortex microcontroller. Yes, that's STM32 family of 32-bit microcontrollers. And datasheet, and that's what we were looking for, which is nice. STM microcontrollers, STM32F, and then F, and then what we've got else. 1.5, that's not CGN. Okay, there are number of them, but this microcontroller, if it's faulty, let's say, yes, if it's faulty, we might not fix it, guys. Okay, there is a number of them. Okay, there's a number of them, but which one it is? 215303 071B GQ203, maybe that's the case. GQF. I don't see this version here, and there is like ST, it's all of them. Okay, guys, you know what, I think I'll need to leave it for now, because I will take too much time. I can pause this recording and I can try to Google it more. We will see, you know, we will see if we can do something about it, because once I know which one it is here, if I can see it on the datasheet, I can check if the voltage supplied is the proper voltage which we would need for this microcontroller to work. and then when we know if the voltage is correct, we see if this voltage is coming in or not. Yes, if it doesn't, then we need to fix it. If it is, then we know that this microcontroller has a proper power supply. Now the signal, if there's any signal which need to comes in, like a switch on, switch off, yes, if that comes in, then we look what else it requires, yes, maybe some temperature or something, or short circuit signal or whatever it requires. Yes, if it doesn't require anything else, if we've got all the things which we should supply, yes, and it does not work, then we know we need to replace this microcontroller. Yes, that's how I understand it. But the problem as well is that we might not fix this device even if we will switch on this microcontroller. But that's different stuff. But that's how I analyze. That's how I see, you know, the faults. So I'll look, and I don't know how long it will take me because I need to do other stuff as well. 203. Yeah, I don't. Guys, I'll try it. If I won't find quickly, because you know I'm not editing these videos, yes, then at least you know how I'm analyzing, how I went into this conclusion, how I knew about things, so you know how to analyze after this video. Hopefully that is something valuable for you in this video. Thank you guys, and see you soon. Okay guys, I've looked and I see that there's only one from these what I'm looking at. It's only one version with 32 pins, because it's 8 by 8, that's 16 times 2, that's 32 pins, pin out, yes. Only one of this kind, and the rest, yes, the rest are 64 up to 200 pin out, yes, about ish. So I can't talk any further. I need to check what I'm looking at, and I need to find exact match. In general, voltages in those STM32F30, yes, in those the voltages are okay. They are not VCC, they are VSS. So it's a voltage source, and VDD, which is a voltage drain. But it doesn't matter. You know, you can check that they've got similarities, yes, and they don't have on the pin 1, they've got on the pin last one and before the last one, yes. So the pin 1 is not the voltage, that's what it is. But anyways, you should see voltage, and I've seen voltage on those like 2 volts. So even if we will now plug in these 12 volts, okay, supply 12 volts, 0, good. Now we will take probes, and I will try to show for this. Yes, this one is okay. See, that's the chipset. Let's check if we've got, I don't know why these two are connected, but okay. Oh, that's AC, sorry. Nothing, and I'm touching the minus. Nothing, let's switch on to 1. I've seen before voltage here coming in, so I don't know what I'm doing wrong now, but I remember seeing the voltage. Okay, and I don't see now, which is a bit suspicious. So it should be either on this pin, like either on this side or on this side. So it's not on this side, so this should go under this via. That's only 0.2 volt. So you see, I need to be 100% sure of what I'm doing. Because if I'm not 100% sure, I might assume something. I'll switch off the voltage and let's try to scrub this. This thing. They are connected together. So these two are connected, they are soldered together. So no matter what we're trying to do, we won't segregate them because that's probably what has to be. They have to be connected. So yes, I need to find now schematics for this particular model, and I need to follow that back. That's the whole procedure. Hopefully you've got a value out of it. So we know now that even though the voltage was coming into this chipset, because I was checking before and it was, I don't know why, I will check. I need to make sure that the voltage is coming in. And if that's the microcontroller I'm looking at, yes, I don't see this particular model. I see the family of this, yes, and I see even 32 pin edition, which is okay. The voltage match the spec, so I know that this microcontroller receives what it's supposed to receive, but it doesn't let go on the whole system probably. So I need to have a way to test it. Yes, if I'll test it and if I'll see that that's the case, then I will leave the customer choice of either, you know, trying to solve it via replacing this microcontroller or just, you know, give up on it. Yes, because what else I can do? I'm no expert with those sine wave inverters. I'm no expert in them. So I can try to write to this company and see if they are keen to, you know, to supply something to help, but knowing life, they won't. Yes, knowing life, they won't, and you know, that's their choice. If they don't, oh well, you know, what can we do? Things are sometimes fixable, sometimes not. That's why we're fighting for the right to repair, because that's the life. But for sure, you know, for sure, if we can fix it, that would be a nice thing, because I've heard that this is a good company, and you know, they are, let's say, they are worth having. Apart from that, so you know, if they could supply spare parts to their own staff, that would be awesome. Yes, because we would know that we can trust one more company in the world. But for today, you know, you see how I'm analyzing things, you see how I go into the conclusion. I'm always looking at power rails, if they are shorted or they are not shorted. I'm looking if the power comes into the place where it's supposed to be, and that's it. You know, you get always either power or the signal. Yes, always. So yes, the most faults to be true are like easy ones. Yes, you get less of those faults which are, you know, like, oh, how to do it, you know, you can't find resources online, you don't know how to do it. Yes, most are the thing which you can either know it by looking it or by measuring it. Yes, or by applying some voltage on it, or by freezing. And you can go into the conclusion quite quickly. Or what's happening is you can literally Google it. Just Google it. A few minutes, you Google it, and you know. But at least are those hard ones. So that's a good thing. Yes, at least. But that's it in this episode. I can't tell you anything else. I'd say that that's more than enough. That's 40 minutes recording even. So that's a, hopefully you get some value in it, out of it. Hopefully. And see you in the next video. Take care. Bye bye.